Scientists have reported a mysterious signal from space that repeats roughly every hour. The intriguing part is that this isn't just any signal. It's been published in the respected journal Nature, which means it's a credible scientific discovery. Let's explore what this might be, though we may not fully understand its origin just yet. Radio astronomers worldwide are currently building a massive radio telescope so large it can't fit on a single continent. It's being constructed in both Australia and South Africa and is known as the Square Kilometer Array telescope. While a square kilometer might not sound huge, this refers to the total effective area of all its antennas combined. These antennas are spread across vast distances to improve the clarity of the radio images. The first phase of this telescope is nearing completion in Australia, and astronomers there, along with colleagues from England, have detected a fascinating source of radio signals. These signals reach Earth with a period of about 1 hour. At first glance, it might seem like Earth-based interference, but the actual interval between pulses is precisely 53 minutes, not an exact hour or a round number of minutes or seconds. This suggests the signal likely has a non-terrestrial origin. Radio astronomers often pick up signals that turn out to be interference, but this one is different. It has 3 distinct phases or modes. One mode is complete silence, no signal at all. The second involves powerful bursts lasting tens of seconds, from 10 to 50 seconds each, followed by a nearly hour-long pause before the next set of bursts. The third mode consists of very weak signals, each lasting less than a third of a second. This behavior doesn't match any known cosmic radio source. Periodic signals are common in rotating objects, especially those with short periods. We've known about pulsars for over half a century. These are compact, rapidly spinning neutron stars with strong magnetic fields that generate regular radio pulses. The faster they spin and the stronger their magnetic field, the brighter the radio burst. However, a period of about an hour is unusually long. A neutron star spinning that slowly would likely stop emitting strong pulses. Another hypothesis involves white dwarfs, the dense cores left behind when sun-like stars die. These can rotate with periods of minutes to hours and sometimes emit radiation, but not like the signals detected in Australia. Of course, there's always the possibility that this is an entirely new type of astrophysical object, discovered for the first time through its pulses. Could it be a signal from an extraterrestrial civilization? Possibly, but there's no recognizable information encoded, no Morse code-like patterns, and no clear way to interpret any potential message. Studying this object is relatively straightforward because, although it was discovered by radio telescopes in the Southern Hemisphere, it can also be observed from the Northern Hemisphere, where there are more radio astronomy facilities. The source is located within the Summer Triangle, formed by the bright stars Vega, Deneb, and Altair in the constellations Cygnus, Lyra, and Aquila. This triangle is well known to astronomy enthusiasts and is visible in the night sky during summer and autumn. In the coming months of 2024, radio astronomers globally will focus on this object. Its discovery is a significant achievement because, despite the infrequent and short bursts, astronomers managed to detect it while scanning the sky. The nature of this signal will remain a mystery until more observations are made. In recent years, we've detected short radio signals from magnetars, neutron stars with incredibly powerful magnetic fields. These might be the source of the rare signals observed now. The object's position in the Milky Way's plane suggests it could be a massive, young object resulting from a supernova explosion. While there are indirect hints pointing to a neutron star, definitive proof is still lacking. Astronomy is an expensive field, both for amateurs and professionals. For example, the total cost of the Spectre-Rargee Orbital Observatory was around 500 million euros. Even amateur telescopes can be costly. The key is using finances wisely, investing in projects that yield long-term benefits. This brings us to the importance of managing money effectively, including making investments that generate returns. To help with this, consider using smart investment apps that offer curated stock selections from experts. You don't need a huge amount to start. Just a few thousand can get you going. Many platforms provide free education, support for beginners, and even bonus opportunities like high-interest deposits or free shares when opening an account. Check the description for more details. Since we're discussing unusual cosmic signal, let's revisit some puzzling episodes in astrophysics that long baffled scientists. One of the earliest mysterious signals was detected in 1966. At that time, the search for extraterrestrial intelligence in the radio spectrum captivated many. Natural radio signals, whether from space or Earth, typically have a broad frequency range. Think of a lightning strike during a storm. Your radio picks up noise across many stations because lightning emits a wide range of radio frequencies. Artificial signals, however, are usually narrowband, focused on a specific wavelength. In 1966, a very strange, powerful, narrowband signal was received on a wavelength of 18 centimeters. It seemed too precise to be natural, leading many to suspect an alien civilization. However, the signal wasn't modulated. It carried no Morse code or obvious information. About a decade earlier, the invention of the maser, a device that amplifies microwaves through stimulated emission, was a human achievement. How could nature produce such a signal? It turns out that hydroxyl molecules, which are fragments of water molecules missing one hydrogen atom, can emit natural maser radiation under specific conditions in dense interstellar gas clouds. Before this was understood, the signal was dubbed mysterium, following astronomy's tradition of naming unexplained phenomena before their nature is revealed. For instance, coronium and nebulium were once mysterious emissions later identified as familiar physical processes under extreme cosmic conditions. The universe often creates and utilizes phenomena we can't yet reproduce in labs. In 1967, Jocelyn Bell, a graduate student at Cambridge, discovered strictly periodic signals using a newly built radio telescope. The signals were so unusual and regular that they were initially kept secret for 4 months. The team even jokingly referred to the source as little green men, hinting at the possibility of an extraterrestrial origin. This discovery ultimately led to the identification of pulsars, rapidly rotating neutron stars, marking one of the most fundamental breakthroughs in astrophysics. A Nobel Prize was later awarded, though it went to her supervisor rather than Bell herself. It's quite common to hear about eerie sounds from Jupiter, Saturn, or Venus. But can we actually hear sounds from space? Not really, because space is a near vacuum where sound can't travel. So what are these sounds we encounter online? Space probes sent past giant planets or into Venus's atmosphere carry detectors for radio waves, magnetic fields, and other signals. These readings are sometimes converted into the audible range for public engagement. While these sounds aren't literal cosmic noises, they offer an intriguing way to experience data from other worlds. For instance, you can find recordings labeled sounds of Jupiter or cosmic noises, which are often electromagnetic oscillations adjusted to fit human hearing. Professionals sometimes even listen to these converted signals to detect patterns, like the chaotic noise indicating a spacecraft passing through Jupiter's magnetospheric shock wave. In my view, one of the most fascinating recordings was made by Leonid K. Sanfamilidi, a well-known planetary scientist. He included a simple radio receiver, a lightning detector, on a Soviet Venus probe. It picked up signals from lightning discharges in Venus's atmosphere. K. Sanfamilidi suggested these might indicate active volcanoes, since on Earth, volcanic eruptions for decades, no active volcanoes were confirmed on Venus, but recent radar images have revealed fresh lava flows, and infrared detectors have identified hot spots likely from volcanic vents. This supports the idea that Venus is volcanically active, with dozens of possibly active volcanoes. The first clue came from K. Sanfamilidi's detector, and you can find these storm sounds online. Thank you to the podcast studio and the university for supporting this discussion. Now, back to mysterious cosmic signals. Fast radio bursts were first detected by Australian astronomers at the Parkes Observatory. These are extremely short radio impulses from space that initially didn't repeat, making them hard to verify. Skepticism arose, especially after a humorous incident where a microwave oven signal was mistaken for a cosmic burst. If you open a microwave door before it shuts off, a brief radio pulse escapes, which the telescope could pick up. However, similar signals were later detected by the Arecibo Observatory in Puerto Rico, confirming their cosmic origin. These bursts last hundredths of a second, implying the emitting region is very small, perhaps even smaller than a planet. The origin of these bursts remains unknown, though many hypotheses have been proposed and discarded. One leading idea involves neutron stars with unusual magnetic properties, specifically magnetars. Interestingly, Russian astrophysicists, including Dr. Popov and Postnov, were among the first to propose that these bursts result from sudden releases of energy from incredibly strong magnetic fields. The energy density in such fields is immense, and even small reconfigurations can release powerful bursts of radiation. This concept is somewhat similar to solar flares, but on a vastly more energetic scale. Early explanations included the evaporation of microscopic black holes, a theoretical possibility predicted by Stephen Hawking. While such tiny black holes weren't thought to exist naturally, recent theoretical work suggests they might form in collisions of larger black holes, which we now observe via gravitational waves. If they exist, their evaporation could produce brief radiation flashes, including radio waves. So, old ideas that weren't initially confirmed can sometimes resurface with new evidence. I often tell students to revisit interesting older research. Ideas that align with natural laws might eventually be validated as observational techniques improve. A strange X-ray signal from the Perseus constellation adds another layer of mystery. This region contains a dense cluster of galaxies filled with hot gas at around 100 million Kelvin, emitting mainly in X-rays. Observations by advanced X-ray telescopes like Chandra and XMM Newton revealed an unusual spectral line that doesn't match any known physical process. This has led to speculation about dark matter. Specifically, it might relate to sterile neutrinos, a hypothetical fourth type of neutrino that rarely interacts with other matter. If these particles annihilate each other, they could produce X-ray photons. While still unconfirmed, this idea is compelling and aligns with ongoing efforts to detect dark matter. Finally, one of the most enigmatic signals in the search for extraterrestrial intelligence is known as SHG-BTWO plus 14a, identified by its coordinates. This signal was detected as part of the SETI at Home project, which allowed home computers worldwide to analyze radio telescope data for signs of intelligent patterns. It was detected near the 21-centimeter wavelength, which is significant because hydrogen, the most common element in the universe, emits at this wavelength. Many have suggested that 21 centimeters would be a logical choice for interstellar communication. The signal's frequency shifted rapidly, suggesting the transmitter was moving back and forth relative to us at high speed, much faster than Earth moves around the Sun. This rapid motion is puzzling and doesn't fit typical planetary motion. While it appears artificial, the explanation remains elusive. The universe continually surprises us with phenomena beyond our imagination, offering incredible discoveries that expand our understanding. To stay updated with more fascinating insights about space, make sure to subscribe, like, and share this content. Let's connect across the cosmic void and keep exploring together.